Hello and welcome to IT Chronicles. My name is Casanova and we're here in Las Vegas at the Gartner Data Center Conference. I'm here with my co-host Charlie Betz.
Carlos.
And Steve Pao from Igneous Systems.
Hello.
So Steve, I haven't seen you around. It seems like there's almost, it's been sort of stealthy, kind of thing. Just,
That's the term.
You kind of pop out of nowhere. And
That's
what's going
right.
on with you guys?
We actually emerged from stealth on October 11th of 2016.
Wow.
Congratulations.
Thank you. So it turns out the company had spent the last 3 years in R&D.
That's a lot of time.
Yeah, so it turns out that the company was founded late 2013, raised both its seed and Series A round from the likes of NEA, Madrona Ventures, and Redpoint Ventures.
Right.
And basically we've been heads down doing product development. We've had 11 patents already granted to date. And
Wow.
so the only thing that was disclosed about us really was what we had to file with the patent office.
Yeah, and that you actually exist to the market space. So what exactly is it? What are you guys doing?
Well, essentially what we're doing is we're providing what we call true cloud for local data. And we see ourselves at the convergence of two really big trends. One is one that's often told really about the growth in data that's out there, and the growth in data really coming from the increase in data generators, machines generating data.
Sure.
The second is really this whole economic trend for businesses to consume IT as a service.
Yep.
And so fundamentally, what we're doing is we're actually providing the ability to curate these very large data sets, but doing so on the customer premises where it doesn't have to move to a public cloud, but offering it as a service.
Wow.
Got it. So your product is acquired as a service on-prem. The customer is not actually buying the capital.
That's correct.
Okay.
That's correct. And really, the motivation, for doing this was, our founding CEO was a guy by the name of Kiran Bageshpur. Prior to founding Igneous, he was the VP of Engineering for the Isilon storage division at EMC. Are you familiar with Isilon? Yeah. So it turns out that one of the things that these guys got to see were how the very largest hyperscale providers were actually stressing the Isilon environment. And one of the things that some of these very large hyperscale providers did was they went and built their own storage. So they went and these are the likes of folks that EMC's not allowed to name. I guess I can, but folks like Apple and Facebook and others who were using that kind of infrastructure, who ultimately went to go build their own. But what's interesting is also at the low end, they were saying that that there was really this trend where the public cloud was eating away the low end of the business. So really what Igneous was really the convergence of saying, how do we build a very large, scalable infrastructure, doing it in a way that doesn't require a lot of maintenance, where it can be hands-off to the end customer, and offering it really as a service.
So I guess there's two things that kind of come to my mind with that. One, it seems like they could almost do a lot of the same work without a lot of the resources and headaches that come with that. And secondly, from privacy and security, especially like medical or any kind of those things, you're offering them the capabilities of not going there but doing it in-house and still having that scalability and everything.
Yeah, actually, you're kind of a good lead person for this, because it turns out that one of the things that we often articulate is that we're for data that either can't or won't move to the cloud. And so what the can't really describes is sort of the physics and the speed of light of moving data around. The won't is really about how you comply with policy and regulatory concerns.
Data sovereignty.
And really often it's the organization simply don't want to move the data to the cloud, not because the cloud's insecure, but really because there's some extra hurdles to go over to meet the needs of the regulatory environment.
Right.
Yeah, this whole concept of data having gravity, I think we saw a dramatic example of that when Amazon last week rolled a semi-truck across the stage.
Yes, snowmobile.
I don't know if that was gravity or like that's really locked to the ground. That's a big trailer.
Because at the end of the day, a FedEx truck still has more bandwidth than the biggest pipes on the internet.
That's right. My favorite quote is that you could sail a petabyte of data from San Francisco to Hong Kong faster than you could send it over the internet.
Yeah,
I saw one of the articles, not to kind of go off of it, but it was something like like going from 20 years to 6 months that they're offering. So something like what you guys are offering, saying, well, you don't have to worry about the 6 months.
Yeah, just don't move it.
Don't move it.
Because there's a real cost in modern data pipelines to taking the data offline. Really, when you look at this new 21st century data pipeline, it's about data sets that are really big and about not really moving the data. So it's what operations can you do while you're ingesting the data? Right. How do you decorate the data with information from other data sources, and how you run transformations in place? And so a lot of the move toward buzzwords, whether it be stream processing, whether it be event-driven computing, whether it be containers and microservices, are really about how you put your code and your code structure around your data, rather than the old way where you'd ship the data across a storage bus to a compute array to compute it, then put it back.
Yeah.
There's just a lot of moving
traffic.
data around. And
Yeah.
so this is really this whole new workflow. And truthfully, I think Amazon has been really at the forefront for empowering data-centric computing, which is that for the kinds of applications where you can deal with bulk uploads, things like Snowball can be realistic.
Sure.
But for the kinds of folks that are actually running continuous data pipelines, often it makes sense to keep that data on the premises.
Right. I think this could be this is going to be a structural factor, and I think that there's a lot of folks who say, well, it's just all going to go to the cloud, but, I do think that data gravity is a countervailing force in the market, and people are going to have to increasingly.
And it has, and I think that the challenge with, traditional forms of data gravity have really been in the economics. Right. I mean, if you think about the old school traditional infrastructure, there were upfront capital purchases, and even when you wanted to put in, services, whether it be an IBM Global Services or an HP Enterprise Services or any of the service arms, they were very, very labor intensive.
Yeah.
And so the only way to really bring cloud economics into the data center is by going back to first principles.
Right.
And in our context, what that really meant was taking a page from what the cloud hyperscale providers do in managing their fleet of inventory and bringing that to an on-premises service. So if you think about it, what Amazon does is they are managing their fleet of inventory at their own data centers at hyperscale. What Igneous is doing is utilizing those same hyperscale management techniques, but doing it across our fleet of inventory scattered across multiple customer data centers. But you've got to use those same kind of hyperscale techniques. And moreover, what you have to do is you have to develop a hardware platform at the far end that can actually fail in place. If you think about whether it's disk drives or memory or CPU failing,
it all fails.
Yeah, it all fails, especially at scale.
Yep.
And you can have a really big blast radius.
Right.
And so the technical innovation at Igneous, much of which was based on what we call an architecture called ratio perfect, was about how you basically assign CPU and redundant Ethernet to every disk drive. Right. So we call that a nano server. And so as we actually bring together our platform, it's comprised of distributed nano servers. That way, if memory fails, you've just lost a drive. If a drive fails, you've just lost a drive. If a CPU fails, you've just lost a drive.
You've isolated, really isolated those.
Exactly, and through an extensive data protection scheme, you can actually let components simply fail in place. It's not an emergency. In a traditional storage array, let's say you're using RAID as an example, the concept there is if you lose a drive, you better very quickly replace that drive. Otherwise, you could actually lose a very large data set in an array.
Right.
In our scenario, if you lose a drive, you lost a drive. You can move on with life.
Yeah, so this is great. I mean, obviously just come out of stealth, so now I guess we're expecting a lot of noise from you guys. So I'm looking forward to, over the coming months and years, seeing how you guys are growing with that, the market space that you're growing into, and then, come on board and let us know how that's playing out. And great to see you again on this.
Yeah, that'd be great.
All right,
Thanks so
great,
much.